we're going to move into interpreting derivatives in context, and these are topics 4.1 and 4.3 in the AP Calculus curriculum, at least as of 2024 it is. So you should have very recently learned all of your differentiation techniques, and Unit 4 in AP Calculus is where you start using your derivatives to answer bigger questions. And so let's talk about derivatives and a couple of reminders, things you should already be aware of, and that is that your derivative can be used to find the instantaneous rate of change at a function at a point. That is the same thing as saying the slope of a function at a given point. And both of those are the same thing as saying the rate of change of f of x is evaluated by finding f prime of c. Those kind of floated off in weird spots. So just some reminders that the derivative is used to find slope, the slope of a tangent, the instantaneous rate of change, but the derivative is tied to slope of a function. And something I forgot to mention a second ago, if you're a random person on the internet and you would like this sheet to follow along and come fill in the blanks for notes, you can go to this bit.ly link right here. My students all have a hard copy of this. So that was a review of derivatives and what derivatives can be used for. What we're going to do is connect the derivative to the function. What does f prime, what does the derivative tell you about the function? And we're going to start off with f prime being positive at a given point. Well, if the derivative is positive, derivative is found to use for slope, then that means your function has a positive slope, which means your function will be increasing at that point. So if your derivative is positive at a point, your function will be increasing at that point. And similarly, if your derivative is negative, then your function will have a negative slope. And if your function has a negative slope, then you will be decreasing. And so graphically, we're looking at something like this for number one. A positive slope means that you have a x-axis and a y-axis, and your function always is increasing, always increasing. And then negative slope means your function will always be decreasing. Now, I don't know how quickly it'll be decreasing, at what rate we're decreasing, but we do know we have a negative slope. So let's go on. We are going to be looking in this topic at functions that represent something very specific. So it could be like the number of people that are entering a store, or the one year it was the sand at a beach as the tide washed away sand. There was a function for the amount of sand on the beach, and then they were replenishing the sand, and all these different contexts. And in these problems, when you are interpreting something, you need to make sure you include the units, and they will almost always, or they will, tell you to use correct units. And when you are using f prime, your units for the derivative will be your y unit divided by your x unit, depending on the context of the problem. So your vertical axis divided by the horizontal axis, or your dependent variable divided by the independent variables units. And that all kind of makes sense because derivatives are a reference to slope, which is change in y over change in x. So it makes sense that we would use units for y over units for x. In calculus, when we do the slope at a point, those deltas are represented with d's because we do not have a measurable change. We're sitting at a single point, but we are doing slope, so y over x for your derivative units, and that makes sense. And when you are interpreting the meaning of a derivative, you must restate all numbers that are involved in evaluating the derivative. That means the input as well as the output, not only the value of the derivative, but the number that you use to get that value. And so that includes not only the value that you achieve, but make sure you include the units and also include the meaning of the x coordinate that provided that derivative value. So you want to make sure you restate everything that is requested. This is just an overly simplified interpretation, and I mentioned this earlier. Derivative positive means function increases, derivative negative means function decreases, and that was earlier, but it's pretty important, so I'm going to say it again. If a function has a positive derivative, then the function will be increasing at that point, and a negative derivative means the function is decreasing. And when you are interpreting, you want to make sure that you explicitly state what your function represents, and that will almost always be accomplished by copying verbatim how the function is described in the question prompt. So there will be a spot in the prompt that'll say something like, let E of t represent the number of people who have entered a park after the park opens. And so when we describe E of t, we will say E of t is the number of people who enter the park. And so you look at the prompt and you see how the function is described, and that is what you need to include in your description or in your interpretation. When you are interpreting the derivative, like f prime of 4, you want to make sure you include the word rate somewhere in your description of how your function is changing, because derivatives do indicate a rate of change. And so we are going to make sure that we include the word rate in our answer. And I believe that is it for the general notes. And general notes are very hard to follow along and process because it's just a bunch of words, math definitions and things like that. Are kind of hard to understand until you actually put them into practice. So we are going to look at a few little examples and how these questions can be worded and how we interpret certain answers. So we have here, A of T is the amount of trash in pounds in my garbage can after T hours. So A is the poundage of trash after T hours. The units for A prime of T, so we need the units for the derivative. Well, A prime of T is the same thing as dA dt, so I need the units for A divided by the units for T. A represents the amount of trash in pounds, so that is how we measure the trash. So the trash is measured in pounds, that would be on the vertical axis. I cannot write worth squat, pounds per unit time, and my unit of time is hours. So pounds per hour. And very quick, nothing else to do about that one. I just wanted to first show you an example of how we would derive units with a derivative. Number 2, the number of people in line to get Mr. Reinsch's autograph. He's a teacher here at my school, and this should say after school. I got before and after mixed up, so I'm going to change that to after. So people are lining up to get Mr. Reinsch's autograph after school, and the number of people in line is given by the function r of t. Here, pay attention to units. R is measured in people, T is measured in minutes. What would R prime of 10 represent? Okay, well, we're talking about R prime. We're talking about the derivative of R. So R prime of 10, and I think I'm going to type this because I can type a lot more efficiently and legibly than I can write. So R prime of 10 represents, okay, so R prime of 10 represents, it's the rate of change of R. It's the derivative of R, and so it's the rate of change of R, except I don't want to say of R, because that kind of begs the question, what is R? What does R represent? Well, R is the number of people in line. So instead of saying the rate of change of R, it's going to be the rate of change of the number of people in line to get Mr. Reinsch's autograph. And I move my head out of the way. So all of that is a lot of writing there, but all of this right here represents the rate of change of the number of people in line to get Mr. Reinsch's autograph. All of that is replacing capital R. The rate of change of R is the number of people in line to get Mr. Reinsch's autograph, and like I said, we often get the description of the function verbatim from the prompt, and that's exactly what I did there. So it's the rate of change of the number of people in line to get Mr. Reinsch's autograph, but I haven't described the 10 yet. 10 is part of this question, and so I need to say 10, and 10 is minutes after school ends. 10 minutes after school ends, and that would be what R prime of 10 represents. It represents the change, the rate of change of the number of people in line, 10 minutes after school ends. So there is number 2. Okay, let's jump on to 3. H of T represents the strands of hair. I think I may say the number of, we'll say the strands of hair on my mother-in-law's head, T years after she turns 60. Interpret the meaning of H prime of 10 as negative 427. So here is one where we can go really detailed in our interpretation, because not only did I give you the T value, I also gave you a numeric answer that we have to interpret as well. So the T equals 10 means 10 years after she turns 60, so she's 70 years old. Negative 427, what does that mean? That's kind of the question. And when I'm interpreting these things, I like to think big picture first. And this is in my head. I would never write this down as my answer, but this is my initial interpretation. There's my brain. If H prime is negative, they tell me that H prime of 10 is less than 0, therefore my function H of T, if my derivative is negative, H of T is decreasing. And that is essentially my interpretation. H is decreasing. but h is decreasing is not specific enough. So I can't say h. I need to put in words what h of t is. So I go back to the prompt and I copy it verbatim from the prompt. Let h of t represent the strands of hair on my mother-in-law's head. So all of that is the words that will replace h of t. So I'm going to start with that. So go back to my typewriter. The strands of hair on my mother-in-law's head is decreasing. By the way, all of that was just replacing h of t. h of t, the strands of hair on my mother-in-law's head, is decreasing. So there's a little bit more, but I still have not included the 10 and the negative 427. And so we're decreasing, and a while ago I mentioned in your interpretation, make sure you include the word rate in some way, and that's what I'm doing right here. I want the word rate in my answer. So I'm going to go back, is decreasing at the rate of, and I'm going to capitalize that because you need to include something like that. So we're decreasing at the rate of, at what rate? Well, it's negative 427. However, I've already used the word decreasing, so we're decreasing at the rate of positive 427. Ooh, I need units. The strands of hair on my mother-in-law's head is decreasing at the rate of 427, and this is a unit for h prime. That would be your dependent variable over the independent. That would be strands per year. So I've talked about the function is decreasing at the rate of. I've explained what 427 is with proper units. And I need to now include the 10. And so you can say when t equals 10 years. You can also say for 10 years after she turned 60, or when she is 70 years old. We have a couple of options there when it comes to interpreting the t equals 10 part. I kind of like to keep it simple. I just like to say when t equals 10, whatever unit. There is one other way we could have done this one. One other way we could have looked at this one. The strands of hair on my mother-in-law's head is decreasing. Now, if you didn't want to use the word decreasing, a derivative is a rate of change. And so I could have said, instead of decreasing, I could have said that the strands of hair on my mother-in-law's head is changing. And if I say changing, then 427 wouldn't be good enough because a change could be an increase or a decrease. So if I wanted to say the strands of hair is changing, I then need to say at the rate of negative 427. So if you want to go that route, you can do that as well. I kind of go back and forth. I personally like the decreasing at the rate of 427, but I don't feel very strongly about that at all. So there's an example of that one where we have a very specific time, a value to interpret, and then we make sure the units and everything is good. Let's see, what else do I have here? Okay, W of t is this function. It represents the population of worms in my compost pile. T days after the start of spring. At what is the rate that the worm population is changing 40 days after the start of spring? Okay, this one is kind of a different question. It's almost out of place based on what we've talked about so far in this lesson. But what is this? All of this can be rewritten in a very succinct, quick math language, and I strongly recommend you do that whenever you're doing problems in math where you see a whole bunch of words. If you can translate those words into math symbols, by golly, do it, because it makes it a lot easier to process. W is the population of worms. If I want the rate that the population is changing, that's a reference to W prime. And I want the change at t equals 40. So this is simply asking what is W prime of 40. And something I should have put in these instructions or with this problem is that you are allowed to use a calculator on this one. So I'm going to fire up a calculator and we will get this value by using your derivative at a point command, which hopefully you're familiar with, and we'll simply write down the answer in just a second. Okay, so I just fired up my calculator, and we use the TI Inspire in my class, and you are expected to plug in things like this straight into the calculator without really showing any work. The only work you want to show is that you are finding W prime of 40. So at least write W prime of 40 equals, and then you will write the answer. And on the Inspire, if you don't know how to do this, you open up your derivative at a point command by doing menu, calculus derivative at a point. It'll ask you what variable you want to use. I almost always stick with x, even if 40 is in the written problem on paper. Even if t is a written variable on paper. You press enter, and then all you have to do is enter the function, and I have already done that. The answer is 1.0089. And in AP Calculus, as long as your answer is accurate to the third decimal, you are good, so that would be accepted. You can round that to 1.009 if you so desire. The problem does not explicitly ask for units, but just for practice, let's talk about that, what the units would be. This would be worms, because W is worm, so that's my vertical axis, my dependent variable, worms per, and T is in days. So worms per day. So I'm only getting one worm per day, which is really weak. I need a lot more worms than that in my compost. That was it. I didn't want to go overboard with this video. So there was really just a couple of examples where you're interpreting in context. And then this one where you're getting a specific value, where I wanted to remind you all how to use your calculator to get derivatives at a point. I think I'm done with this lesson.